Alright guys, this should be a short video. We are going to talk about section 2.2, but this is writing equations of polynomials. So we know some things about this polynomial. It has 1, 2, 3 turning points. And 1, 2, 3 zeros, but this one is doing a bounce, meaning it's tangent to, it did not cross the x here. So this is -4 is a 0, this is -1 is a 0, this is +3, but this one has a multiplicity of 2. So if we write the factors, we have x plus 4, with the -4 is the 0. We have x plus 1, because -1 is a 0. And then we have an x minus 3, because 3 is a 0. But in order to make the graph be tangent to and not crossing there, this needs an even multiplicity, so we're going to put a 2. Now, there is some coefficient out here that made it be this tall and this stretched, but the other thing that made it do is it has a negative leading coefficient. So we're going with it's a degree 4 because we have 1, 2, and an x squared is degree 4. But it has a negative leading coefficient because the end behavior is both ends down. So we're going to figure out what this coefficient is because it's not just -1. We need to be exact with this equation. And so we're always given one extra ordered pair that we didn't use. And in this case, the extra ordered pair is, we know it goes through this particular point. So we are going to put in x equals 0 and y equals -25.2, and then we'll be able to solve for a. Oh, we're supposed to be putting zeros in for the x. So we have -25.2 equals some a times 4 times 0 plus 1 would be 1 times 0 minus 3 is -3 squared is a +9. So 4 times 1 times 9 is 36. So over here we have a 36a, and we have -25.2. So if we take -25.2 and we divide by 36, we get -0.7. So we came out with a equals -0.7. So we think the equation is -0.7, x plus 4, x plus 1, x minus 3 quantity squared. So if we go to the calculator, and this time, what's happening? Why can't I minimize this? Nope. All right, this is not where I want this to be. All right, I'm going to go to y equals. I'm not going to check all these because I know what the answers are, but I want to check one to show you how to check one. So we have negative 0.7, and then we had an x minus 3 squared, and an x plus 4, and an x plus 1. All right, so this is what we got for an answer. So if we set the window, we want the window to look as much like this as it did as possible. So theirs went from negative, move this out, negative 50 to 50 for y, and like negative 5 to 5 for x. Struggling with this calculator today, guys. Window, negative 5 to 5, and negative 50 to 50. And we could change the scale on that one to count by tens if we didn't want a million little marks. Graph. Ooh. No, we got this going off the top. Did it go off the top here? Oh, might have gone above 50. So the point, first of all, we could trace that it went through negative 3 or negative 4 it was. I don't remember. Yeah, it was negative 4. Then negative 1, positive 3, and it's doing a bounce there. But then the ordered pair we were given that we're supposed to match up with, okay, this video is a hot mess, was 0, negative 22.5. So if we put in a 0 to find the y-intercept, we do get negative 22.5. So this screen right here shows that indeed, we did get this right, because we typed in this equation that matches this and got what they did. All right, I got 2 more examples and I'm going to go much faster. So example 2, we got a decimal in here that we need to deal with. This decimal is 0.3 repeating, or 1/3. So we are going to call this 1/3 as a 0. And we have negative 2 as a 0 and negative 4 as a 0. And none of them are bounces. So we have an x plus 4, an x plus 2, and an x minus 1/3. Now, the extra point where we're given is up here. We have negative 1/12. That's not a 0. So we're going to plug that in to find the stretch. It's looking like we have 3 zeros, so I would say it's going to be degree 3. And normally a cubic is this shape, so I'm thinking it has a negative leading coefficient, just to think ahead about that. All right, so we have y equals a, and we're going to put in this x and this y. So we have 12 equals a times negative 1 plus 4, negative 1 plus 2, and negative 1 minus 1/3. All right, that gives me 12 equals a times 3. Negative 1 plus 2 would be 1. Negative 1 minus 1/3, you could do it on your calculator, but it's negative 4/3. Ah, guys, look what happens. 3 times 1 times negative 4, all divided by 3. Well, this 3 could divide that 3 out, or you could multiply it and get negative 12 over 3, or you could type it all in your calculator, but you will get negative 4. And that was multiplied by an a and became a 12. If you divide, we got a is negative 3. That's sweet. So our final answer is y equals negative 3 times the quantity x plus 4, x plus 2, and x minus 1/3. Now, somebody's going to ask, couldn't we have written this factor as negative, or, I'm sorry, let me think about that. Written this factor as 3. I'm hopeless tonight. I should have not tried to do another video. It's 8:30 on a Sunday night. I should just have gone to bed. Okay, so if we had an x plus 4, an x plus 2, and somebody could say this would be a 3x minus 1, which would give us a 1/3. Okay, if we had used that and plugged in the negative 112, it turns out this would have been a negative 1 out here. The difference is if you distribute the 3 back into this one, okay, these are equivalent. All right, but it's fine either way. Last example, I think, or did I make 4? Oh, I did make 4. Oh, longer video than I thought. All right, I'll go quick. We have negative 4. Uh-oh. 0 is a 0, and it's a bounce. So negative 4, 0, and 2. This is multiplicity 2 at 0 because it bounced. And it looks to be a degree 4. There's 1, if we do turning points, there's 1, 2, 3 turning points, and both ends are up. So I'm thinking degree 4 positive leading coefficient. An x plus 4 would give me a negative 4, 0. An x minus 2 would give me this 2, 0. And a bounce here, you could write x minus 0 quantity squared. Most of the time we just write x squared. And I put it out front just because that's where we usually write those plain x's. And now we need to figure out what a is that will give us, and the extra ordered pair they gave us here is negative 13.5. Let's see, negative 1 squared, negative 1 plus 4, negative 1 minus 2. So we have negative 13.5 equals, negative 1 squared is just 1. And negative 1 plus 4 is 3. And negative 1 minus 2 is negative 3. So I have negative 13.5 equals a times, all that's a negative 9. If I divide, negative 13.5 divided by negative 9 is positive 1.5. Or you could have written it as 3/2, either way. So final answer when we plug that back in, up here, is 1.5 times an x squared, which you don't really need those parentheses, an x plus 4, and an x minus 2. All right, one last example. What do you want to guess here? It's got a 0 at negative 2, a bounce here, and a 0 at 4, but that's also bouncing. So there's our factors. That would be 1, 2, 3, 4, 5 degree, it looks like. There's 1, 2, 3, 4 turning points. So degree 5 seems reasonable. Normally a degree 5 would be that shape, so I'm thinking a negative leading coefficient. All right, let's try this. We have an x plus 2, degree 1. We have a 0 that was a bounce, so we have an x that's squared. And another bounce, at 4, so x minus 4 is also multiplicity 2 to cause that tangent spot here and here, okay? So we have y equals something, and we're going to replace that a with a number at the end. But first we're going to put in -1 for all the x's. And we're going to put in -5 for the y. And solve for a. So we have -5 equals a times 1 times 1 times -5 squared, which would be 25. So we have 25a, and over here we have a -5. So we get -1/5. And we said we needed a negative leading coefficient to make this shape be accurate. -1/5, I believe, is also -0.2 if you want to use a decimal. So our final answer is y equals -1/5 x squared times x plus 2 times x minus 4 quantity squared, or you could put the -0.2 in there instead of that. And remember, you can always type these in on your calculator and check that they hit every ordered pair that we had on that picture. Make sure your window is set up the same as the picture.